the load carrying capacity of this column section if the length is given as 4.5 meter. One end may be assumed as fixed and another end may be as hinged. So this point indicates to find L. You have to consider this case. If one end is fixed, other end is free, 0.85 times the L. The L is given here 4.5 meter, and if you multiply into 0.85, which will be your effective length. And the grade of the steel is given as 415 E. What do you mean by E is yield strength. This is 250 Newton per mm square. In the code book you have a class PD, that is design load, equals AC, that is area of the section, into FCC. FCC can be found by three methods. I have discussed in last class. The last method is finding the KL divided by R, that is the slenderness ratio. KL is a constant, that is effective length. How will you find effective length? 0.85 times 4.5. Now if you multiply, you will get KL divided by R. What do you mean by R? Radius of gyration. Since you are having x-axis and y-axis, for this problem you have two axes. Always you have to substitute least radius of gyration, that is R minimum only. Refer steel table, page number 12. This is ISMB 400. There you can see IXX. What do you mean by IXX is, here they have given in the problem as IZZ. So your moment of inertia at x-axis is 20458.4 into 10 power 4 mm power 4. This is your moment of inertia at x-axis, and at y-axis you have 622.1. Whatever the moment of inertia they have given here, which is for the I section only, you have two plates additional to it. Find the additional moment of inertia. IZZ, that is IXX, they have given IYY and area. Check the buckling class. What do you mean by buckling class is, they have given a section like this. Before finding FCC, you have to find the class. You have four types of class. What are they? Class A, B, C and D. Which class is built up section? Built up section comes under this component. Table 10. You have built up member, and what is the buckling axis? It can be any axis. It can tilt in Y direction or it can buckle in X direction. Both the directions it can happen, and the buckling class is C. So you have to check the class C. You have to find the revised moment of inertia. How to find FCC? R is required. KL by R, that is the slenderness ratio, isn't it? What is R? Radius of gyration. You have radius of gyration value for only the I section, not along with this plate. So that you have to find R. Formula for radius of gyration: root of I by A. What is A? Cross sectional area. I is moment of inertia. So you have to use least radius of gyration only. Okay. How will you find least radius of gyration? You have to check. You have to first find the I, that is moment of inertia. Moment of inertia at x-axis and y-axis. If you find that, divided by A, you can find in the steel table the area 78.46 centimeter square. Now if you want in millimeter square, you can write it into 100. So it will be in 7846. Now what are the additional areas here? 300 into 20 is a plate. So how many plates you have? 2 plates. So what will be your revised area? Area equal to 7846 plus 2 into 300 into 20. So this will be your revised area. Now how will you find the moment of inertia I? Let us check now. Yes. The sectional properties, first you have to find IXX, that is IZZ. How to find IZ? You have the built up section moment of inertia formula is what? IXX plus area into distance square. IXX is moment of inertia of this section 20458. So you have this value plus What is your additional area? 300 into 20, which is your additional area, into distances. What is the distance from the z-axis to the centroid of this plate? Total distance is 400. So your centroid will act at 200. This distance will be 200. What is the thickness of the plate? 20. Then centroid will fall at 20 by 2, 10. So your distance from the z-axis to the individual centroid is 200 plus 10. Moment of inertia for the built-up section. Now if you add this, you will be getting Iz. 73 into 10 power 6 mm power 4. This is your Iz. Now if you cut in y-axis, the centroid will fall along with the axis for both the plate as well as the I section. Centroid of the plate will be acting here and I section will be acting here. So both are at the same plane, hence moment of inertia of the plate about the own axis is neglected. So you don't have to use this formula. Okay. Now you can simply add the total moment of inertia. What is the formula for Iyy for a rectangle? dB cube divided by 12. What is the depth here? 20. What is the breadth? 300. So 20 into 300 cube by 12. This is your Iyy of a plate. Plus you already have Iyy for the I section. What is that? So can you find this value in steel table? Can you find here? Iyy is what? 622. Now why we have not multiplied by area into distance square here? Because the centroid of the plate will be acting at the y-axis only and the I section both comes under the same plane. Whereas if you cut in x-axis, the centroid of the plate will be at different distance. It will be at one distance and the Ix for the I section will be different. So that we are multiplying by that. If it comes under same axis, just you multiply the answer. So 96 into 10 power 6 mm power 4. Now which is your least moment of inertia? Iyy is the least. How to find radius of gyration? R equal to root of I by A. What is your least moment of inertia? Iyy. Now you substitute Iyy divided by area. Your total area is 19,846 millimeter square. Now what you have to do is divide 96 into 10 power 6 divided by 19,846. You root this, you will be getting Ry. Your Ry will be 69.63. Now if you got the R value, one end is fixed, other end is hinged. This is your case. For that your length will be 0.8 times 4,500, which will be 3,600 mm. Now KL by R ratio is 51.79 C in your code book. This is for buckling class C. What is your value? It comes under 50 to 60. Your value is 51. So it comes under 50 to 60. What is your yield stress? 250. So you have to check for 50 the value is 183 and for 60 the value is 168. What is the value for 51.7? For 50 it is 183, for 60 it is 168, for 51.70 you have to find the value. You can find it by many techniques are there. So one of the technique is, what is the difference between these two? 50 and 60, difference is 10. Difference between 183 and 168 is what? 15. If you subtract 183 minus 168, you will be getting 15. So the difference you can find it here. And what is the difference between these two? 50 minus 51.7 is 1.7. 183 and it will be as unknown, which will be x. You just cross multiply this, you will be finding the value of x. X is 2.55 and you can subtract with 183 minus 2.55 is, you will be getting around 180.45. This is also another technique. This kind of technique also you can use. There are number of interpolation techniques. These are all interpolation. Interpolation can be done by different method. FCD you can multiply with area 19 846 into this value will be getting the design load. PD is design load. So your design load will be 3581 kilonewton. So this is the design load. For working load you have to divide it by 1.5. Whatever value you got here, divide by 1.5 will be the working load. So your working load will be 2387 kilonewton. Find the load carrying capacity, that is working load. If you are providing lesser than 2300 kilonewton, this column will take the load. If it goes beyond this 2387, it buckles. What happens? It will not crush, it buckles, that is it bends. If your column is bending, will you accept? In any of your construction, if your column is 4 number of columns there, if 100 people are occupying that place, if it is buckling, will you accept? Nobody will accept. It should not buckle. In a truss, a strut of 3 meter long. This is a strut component. The previous two problems are this beam problem. A column is being used. Indian standard beam, they are using a I section for the column. Now the compression member not only be a column, it can be a strut in a truss. You can have the strut in a truss. You can design the strut as a compression member. In a truss, a strut of 3 meter long. So the length of the member is 3 meter long, consists of two angles. Angle section is Indian standard angles. A stands for angles. What is the section is? 100 mm, 100 mm 6. Okay. How to understand this is, the length of the leg is 100 mm, depth of the leg is also 100 mm. What is the thickness? 6 mm. This is the way to understand. They have provided back to back. They provided a section like this, and center they have provided a gusset plate. The plate is being connected with the back to back section. Now find the factored strength of the member if the angles are connected on both sides of 12 mm gussets. By the thickness they have given as 12 mm. What are your conditions? Condition number 1, if the three members is being connected by a single bolt, only one bolt is connected between these three members, what is the load carrying capacity? If two number of bolts it is added here, 1, 2, if two number of bolt is added, what will be the capacity then? Then third condition is, if all the three members are welded, you are not bolting, you are just welding. If weld is provided, what will be your capacity? If only one angle section is given, then you can take C. This is built up section. What do you mean by that? You are having two number of angle section. So this comes under this category. Anyway, this also is having a buckling class of C. Now you have to check only the buckling class C. Find KL by R. What do you mean by R? Radius of variation. Can you get it directly from steel table? No, you cannot get it. You will be getting only angle section radius of variation. You have to find moment of inertia I and check the least moment of inertia. If you root I by A, you will be getting R. By that you can find that. From the steel table, number of back to back angle sections. Note here the title, properties of two equal angles back to back. Width and depth both are equal. Under what section it is coming? ISA 100 100 into what is the thickness? 6. Now under this class you have to check what are the data required. You take it from here, cross sectional area. Note that the cross sectional area is given for both the angles, not for one angle section. For both the angle section, your total area 2 3 3 4. They have given moment of inertia, section modulus, radius of variation. What do you mean by CXX is distance from the centroid to the extreme fiber of this component. Now when you cut this in x-axis, the first angle section centroid will be acting here and the second angle section centroid will be acting here. So there is no issue here. But if you cut the component in y-axis, it will be having different y-axis and this component will be having a different y-axis. At y-axis only you need the area into distance square concept. You have taken all the components. What is the radius of gyration? They have given in terms of centimeter, that is 3.09. If you are writing in terms of mm, 30.9 mm. Okay, now see xx or yy is 26.2.67 they have given. You have to write it as 26.7. Also, area of a single L section is 1167. If you multiply by 2, 2334. This is what they have given here. 23.34 is 2334. They have given both the area. Here only one area is taken. Okay. Now after taking this, find IYY. IYY plus area into distance square. What is your IYY? Do you have moment of inertia about y-axis for this angle section? 222.6. Note here that for an equal angle section, this section is equal angle section. Your IXX and IYY both will be same. Why? It is equal angle section. Your length and depth is same. Hence, you can take this as IXX as well as IYY. Now your IYY is 222.2 into 10 power 4 plus area. See, do you have area here? 23.34. So your IYY is 222.6 into 10 power 4. Your area they have given is 23.34. Everything is written in terms of mm. Now, what is this distance square is? What is the distance from the centroid to this individual centroid? Now you have to use Cy. They have given this as Cx. And what do you mean by Cy? Is the distance between this centroid to the extreme distance. So what is the distance? What is the Cy? 2.67 centimeter, that is 26.7 centimeter. So you have to add 26.7 plus what is the thickness of the plate? 12 mm. The half of the 12 mm is 6. So this will be your IYY, 4.7 into 10 power 6. Now you can find the radius of gyration. IYY divided by area. Now you will be getting RY, 44.98. Now after finding this, which is higher? You know RX and RY, which is higher? Now RYY is 44.98. What is RX? You can check here. What is RX? 3.09, that is 30.9. Is 30.9 is greater or 44.98 is greater? Okay, now you have to take which one? Least as the radius of gyration. So you can take 30.9 as your radius of gyration. Now your radius of gyration is 30.09. Why we are taking 30.09 as it is? Because it is in symmetry. In x-axis it is in symmetry, hence you are taking the radius of gyration value from the table. Now after finding the R, come to case number 1. What is your first case? When you are having single bolt. Now you have all the components for solving the problem. Just you have to find KL by R. R is fixed. What is that? 30.9 is fixed. Now what is the varying component? KL. You change the KL for different cases, you will be getting 3 answers. For first case, your length will be 3000. When you are using single bolt, it is hinged connection. If both the ends are hinged, so what is your L? 1L. Hence you can use 3000 divided by 30.9. You will be getting 97. Table 9C, you will be having, see, for 90 you got 121, for 100 you got 107. So in between that you got 111. FCD can be found out 121 minus 7 by 10, 121 minus 107, you will be getting 111.2 Newton per mm square. Okay, if you substitute this in FCD, you will be getting 259 kilonewton. This will be your design load. PD is design load and you can find working load, which you can divide that by 1.5. So this is your design load. Okay. Now come to case number 2. Case number 2 is okay. Now the next case is when 2 bolts are used. Top 2 bolt, bottom 2 bolt. Only one component is going to change. That is R is constant. R you have already found. That is 30.9. Only thing is K is going to get changed. If 2 bolts are used at top and bottom, you can reduce the effective length as 0.85 times actual length. You have 1L for both the ends hinged, and for both the ends fixed you have what? 0.65. Now your condition is, can you take bolt as fixed end? You cannot take it as fixed end. Can you take bolt as purely hinged? If one bolt is there, you can consider it as hinged. Why? Because there is rotational possibility. 10 number of bolts are there. Then the possibility of rotation also gets reduced. So, if 2 bolt or more than 2 bolt are used, it is better to go in between that. What are these values? You can take lesser than 1 and greater than 0.65. For fixed it is 0.65 and for hinged it is 1. So it should be in between that. Hence in this problem it is taken that 0.85. So for your exam purpose you take it as 0.85. When 2 bolts are used, you have to take 0.85 L. Now your value will be 2550. If you divide with 30.09, your value will be 82.5. Now you can check the same table. For 80, which is 136, for 90, which is 121. You have to look it for 82.5. Your value will be 130. For 80 it is 136. For 90 it is 121. For 82.5 it is 132.25. Now you multiply with this into area, you will be getting the answer. .6 kilonewton. Now the third case, rigid, that is welding. Here it is taken as 0.7. You can take 0.7 or 0.65, both you can take. If you are taking 0.7 by L, you will be getting 2100 divided by 30.9, which will be 67.96. Your values will be 60. For 60 you got 168. For 70 it is 152. 155.26 is your answer, and you can multiply with the area, 362 kilonewton. Now, what is the best connection? The last one, welded design gives 362 kilonewton of load carrying capacity for buckling. Now, what is the worst type of connection? If you provide only one bolt at both the joints, so what was the load carrying capacity there? 259, that is 260. See, can you find 100 kilonewton capacity? 100 kilonewton is not simple. A lorry which will be having 30 to 35 kilonewton. Then you just remove the bolted connection and you make welded connection. You can add how much of weight? Around 100 kilonewton of weight can be increased. Always a compression member design depends on radius of gyration is increased, load carrying capacity will get increased. That is your concept here. When you design more and more components, you will be knowing that if you increase your radius of gyration, the load carrying capacity will get increased. Providing fixed end or welded, you will be getting more load carrying capacity. So this is your understanding.